Okay. My dear students, please make a note of this problem. This is a problem which is asked for 10 marks in your examination. Yeah, take down. For 50 H8D8, for 50 H8D8, compute clearance if the p spot errors are first one, uniformly distributed, second one, normally distributed, third one, 1 sigma truncated normal distribution, and the fourth one is 1.5 sigma truncated normal distribution. 1.5 sigma truncated normal distribution. Yeah. So I think when you just look at this 50 H8D8, can anybody tell what is this indicates? Yeah. Could you able to get my question?
Yes.
What is this 50 H8D8 indicates? I think you might have studied this in your engineering metrology when you might be there in the 4th semester or 3rd semester. This kind of representations you might have been come across over there. Would you able to recall? No. 50 H8 and D8. Definitely you might have studied, you might have solved many problems on this kind of things. Sukrut, could you able to recall?
No, sir.
Danush? No.
No, sir.
What about Sandesh?
No, sir.
No. Very long back you studied, huh?
Sir.
Maybe 15, 20 years back you might have studied these things. Those were you could not able to remember. Harsha, any idea?
Sir, no. Just ಸ್ವಲ್ಪ
Sorry?
No, sir. Just,
You don't remember. Yeah. See, this type of representation is for a fit. Fit, I think you might have heard. A clearance
okay.
fit, interference fit, transition fit. Have you heard that at least fit?
Yes, sir.
Yeah, sir.
So this,
It's not problem.
yeah, this is a representation. Sorry? Anything?
Sir, I guess 50 is the nominal diameter, sir.
50 is the?
Nominal diameter, sir.
I didn't get you. What diameter?
Nominal, sir. Nominal.
I'm sorry, I'm not getting the word. What is 50?
Sir, 50 is the nominal diameter, sir.
Nominal.
Nominal, sir.
He's telling nominal.
Nominal. Okay. I'm sorry. I'm just it's just like a nominal. Okay. Yeah. See, this kind of representation we call it as for a fit. Okay. So generally, a fit is represented with a hole and a shaft. Okay, I think just you might have studied in your engineering metrology when you are in the third semester or fourth semester of your engineering.
Yes,
So
sir.
hole
Fits and
and
tolerance.
sorry,
Yes, sir. Fits and tolerance.
yeah, we might you might have solved so many problems on this. I remember. I just I can get that done right. But thing is, you have to remember. You cannot to forget so easily everything, right? So this is a representation of a fit. And when you come to this 50 capital H8 and small d8, this is representing 50 represents the basic size or a nominal size, anything you can call it as. It is a basic size. And capital H is used to represent for the whole. Capital letters are used for representation of a whole. And 8 is the tolerance indicator or tolerance zone or tolerance grade, we can call it as. 8 corresponds to the tolerance grade. And coming to the last one is a small d. Small d is used for representing a shaft. Means small letters are used for representing a shaft. And of course, 8 is a tolerance grade. Okay, so what this entire 50 H8 D8 represent, it is a type of a fit. Okay, so when you go for data handbook, so metrology data handbooks, so there you can see what is the tolerance grades. Different tolerance grades will be given, and you can easily match 50 H8 and D8, which will corresponds to what type of fit it is, whether it is a clearance fit or a transition fit or an interference fit. So this is, please remember, this is a very simple thing and very important thing for you to remember, because these are all the common questions and basic concepts. So this is a representation of a fit. So where first letter, the first numerical value represents the basic size. Second will follow the first will be the basic size, followed by the hole indicator. Capital letter which represents for a hole, and followed by a numerical number represents the tolerance grade, and then followed by the shaft, which will be always represented in a small letter, and followed by the tolerance grade. So in this case, what we are showing it is 50 H8D8. It is a type of a fit for which compute the clearance. If the p-spot errors are uniformly distributed, normally distributed, 1 sigma truncated distribution and 0.5 sigma truncated distribution. So these things, of course, this part is uh, later part. First, we have to calculate what is the what we call it as the clearance for this. Okay, so of course this definitely requires a data handbook. Without data handbook you can't do so, but I've just given here, and you can just make it these things here, right? So given 50 diameter 50 H8 D8 from the data handbook, recommended step diameter be 30 to 50. I think this, if you just look at this, you can recall what the problems you have solved in your metrology part. Would able to get these things?
Yes, sir.
So 50 lies between the diameter step of between 30 and 50. So now we have to calculate what is the diameter, D. So D is the geometric mean of D1 and D2, where D1 is the range what you have given, and the first and the last range. First range is 30, last one is 50. So D1 is 30 and D2 is 50. Please make a note of it correspondingly. You have to do another one problem shortly. Okay, so D1 and D2. So 30 into 50, you will going to get 38.7 millimeter. Okay, so first you have to calculate D. So why do we want to calculate D? Means we have to get the value of I. Okay, what is I? I is a tolerance grade, right? So here we have I is equal to 0.45 cube root of D plus 0.001 times T. Please make a note of this formula. It is I is equal to 0.45 cube root of D plus 0.001 times D. So substituting the value of D as 38.7 millimeter over here. So you can get what is I, which is 1.5597 microns. It is microns. 10 to the power of minus 3. So first you have to calculate I. Is it clear, my dear students, how to calculate I?
Yes, sir.
So, of course, this is required data handbook. I will give you the data handbook. Afterwards, you can do. But at present, you can just practice like this. Okay. So, 50 will lies between 30 and 50 range. This you can get it from the data handbook. So, then diameter D can be calculated by using a geometrical mean of D1 and D2, which is 30 and 50. Calculate 38.7, you will going to get. Okay, then you calculate I. So please check, operate your calculator and get these values, what you're getting is correct or wrong. You have to operate the calculator quickly and you want to get this answers are correct, you are getting these correct answers. D, you are getting 38.7.
Yes, sir.
Yes, sir.
Okay, what about I? What about I?
Yes, sir. We got
See, this I will be always default it will be in the microns only. Okay, so when you substitute D in millimeter, I will going to get it in microns only. Afterwards, you have to convert it. Please remember this. Okay. Next. So once you get that, next thing is fundamental deviation for the whole. Fundamental deviation for the whole from data handbook. Again, you're going to get for whole H8, it is 0. Fundamental deviation for the whole H8 is 0 from the data handbook. Now, so next, please move. Tolerance grade for whole H8 is H8 is IT8. IT8, 8 corresponds to the tolerance grade for us. So, which is equal to 25I. This is standard value. Again, you will going to get these things from the data handbook. Got it?
Yes.
And multiply, substitute value of I and keep it in the millimeter. So you might be getting in terms of microns, convert that into millimeter, you will going to get 0.04 millimeter. Got it?
Yes, sir.
Right. Now, we will going to write the limits for the whole. I think so. All these things, what you are recalled in your lower metrology class, same thing over here. So here, 50 minus 0. The fundamental deviation is 0 for the whole. So minus 0, 0. And the tolerance rate, what you have got is 0.04. This you have to get this. So please go back to your metrology. So how do we write the limits for the hole and the shaft? Got it, my dear students?
Yes, sir.
Make it quick. Okay. Next, fundamental deviation for the shaft D8 is minus 0.08. Again, this will be from the data handbook. Okay. Next, tolerance grade for the shaft D8 is IT8 because it is both the hole and the shaft are of same grade. So we're going to get IT8, it is 25I. And for this also, it will remain same only, 0.04 millimeter. Okay. Next, we'll move on to the limits. Limits for 58 shaft is 50 minus 0.008 and the lower limit will be minus 0.012. Anybody can tell how you got this 0.012? Minus 0.08 is the fundamental deviation. That is the one upper limit. Upper limit is 0.04, 0.08 for the shaft. Whereas in the case of a hole, it should be the lower limit, fundamental deviation. But in the case of a shaft, it should be an upper deviation. And how we got the upper limit? What is the lower limit? How we got lower limit here? Minus 0.012. Anybody can tell? How we get 0.12 minus 0.12, the lower limit?
Deviation of the shaft plus tolerance grade of the shaft.
That's it. That's it. Okay. Tolerance fundamental deviation is 0.08. Okay. So after the class today, if you have time, please go back and check your metrology textbook and look at what is the fundamental deviation, how they have done. Right. So this is 0.08, and for this we have added 0.04. The tolerance grade you are going to get minus 0.1. Please remember this. So the shaft, it will come below the nominal size, whereas for the hole, it will come above the nominal size or a basic size. So anything will be added to the shaft from the lower limit to the upper limit, whereas here from upper limit to the lower limit. Be careful in the case of a shaft, okay? Because the representation, when you represent the what we call it as the schematic representation of a fit, if you look at, so then you can easily understand this, right? So now, so this is how we calculate the limits for the shaft. Okay. Next comes, now for the hole, we have 50, upper limit is 0.04 and the lower limit is 0.04. And we're going to add both the limits and we're going to divide by 2. Please make a note of these things. So we're going to get U for H. U for H is 0.02. Please make a note of it. So what we have done, we have added these two up limits and we have divided by 2. So the U for H, we're going to get 0.02 and X for H will be equal to 0.02, means we equally divide for the whole 50 plus 0.02 and minus 0.02. So totally you will going to get the same thing only over here. So 50.02 millimeter is a standard value, what you will going to get it.
So for the whole, the lower limit is 0.04. So.
Lower limit, not upper limit. Upper limit is 0.04. Lower limit is 0. Because fundamental deviation is 0, no? Next, similarly, calculate for the shaft. Over.
Yes, sir.
Right. So now, once we get these values, now we have to get the sigma value. See, all these things available in our data handbook. Don't scratch your head. Okay, since we don't have data handbook, people don't have data handbook, you may be wondering how these equations have come. Nothing to worry, right? So sigma for H is UH by 3. So you can substitute 0.02 divided by 3. What we're going to get 6.5 and 10 power minus 3. And sigma for shaft is US by H. So UH means what we have calculated previously. So here UH 0.02. Okay. So we have 0.02 divided by 3. You are how much you are going to get. And sigma S is US by 3 again. 0.01 by 3, you are going to get this. Okay. Then we have to get the average of these values, X bar A. Average of this we're going to get 50.02 minus 49.9. These values you can get it. So this is for calculating the sigma value. So you will going to get, please make a note of these things, 0.12 millimeter it is. Then we can get what is sigma, which is the square root of sigma h square plus sigma s square. Substitute sigma h and sigma s here and get the value of sigma. Got it?
Yes, sir.
Sigma value 0.9.
Yes, sir.
So once you get these things, next we'll start with the p-spot distributions they have given. For the first one, logarithmic distribution. For logarithmic distribution, please take it out. U is equal to sigma divided by 0.577. All these things available in data and book, don't worry. So sigma value we have got 0.03392 divided by 0.577. You will going to get the value of which is 0.0588. Now you can calculate what is the maximum clearance and the minimum clearance here. So how do you calculate maximum clearance? XA bar plus U is equal to maximum clearance. XA bar minus U is the minimum clearance. This is for using logarithmic distribution. Okay. Got it?
Yes.
Then second one is normal distribution. In case of normal distribution, U will be equal to 3 times sigma. So substitute the value of sigma here and get the value of U. Then same thing, maximum clearance is XA bar plus U and minimum clearance is XA bar minus U. Same thing. Got it?
Yes, sir.
Okay. Next, I will move on to the third one. For truncated, 1 sigma truncated, for 1 sigma truncated, sigma h is 0.44 times U. It is actually UH actually. This is UH. Please make a note of that. This is UH, not U. It is UH and this is US. This is US and this is UH. I think US and UH we have calculated previously. Those values you have to substitute here. I think UH we have got 0. How much? 0.02 and US is 0.01. Now once you get US at UH, so again you have to calculate, so sorry, sigma H and sigma S, we have to calculate sigma again. And once you get sigma, it is U is equal to 3 times sigma again. Procedure will remain same. Only thing is for truncation, so you might be getting the different values for sigma H and sigma S. So that you have to calculate and you have to get the things done. That's it. Rest of things will remain same. So once you get U value, so again you can calculate what is maximum clearance and minimum clearance by using the same formula. you can calculate what is the maximum clearance and minimum clearance. Were you able to get the answers?
Yes, sir.
Right. Shall I move to the next one?
Yes, sir.
Okay. Next, the last one is for truncated 1.5 sigma. So this is sigma h is equal to 4.96 US, UH and US. So for correspondingly, you can make it as US and UH over here. Substitute and get these things done. It is 0.496 into 0.02.
Hello. Hello. Really cable thanks a lot. Thanks for evening morning.
Yeah. So calculate sigma h and sigma s. And once you get sigma s and sigma h, calculate sigma value. And once you get sigma value, again you calculate u. And once you get u, then same thing, maximum clearance and minimum clearance. Got it, my dear students? Any clarification here?
No, sir.
This problem will carry 10 to 12 marks in your examination. If they ask all the 4 different conditions, definitely it will carry 12 marks. Okay, so it's very simple problem. Only thing you have to make use of the data handbook of that values means. Once I will give you that, no problem.
Sir,
Okay.
second step also.
Second step, this one.
Yeah, sir.
Okay, if you have completed, I will give you an assignment question. I will give you time for 15 minutes or 20 minutes. You have to complete that and you have to post it in the Google Classroom. A similar type of problem. Only I will just change the value here and you can do calculations of your own and you have to substitute. And you have to submit it to the Google Classroom. Okay. Is it over, Harsha?
Yeah, sir.
Yeah. I will move to the question now. Yeah, please make a note of this question. This data, I think you have to get it from the data handbook. So since you don't have data handbook, please make a note of this. Since I have given it is 25 millimeter, 25 millimeter lies between 18 and 30 millimeter range. This is for calculating D. And the fundamental deviation. Shaft is equal to 0. Just a minute. 0.065. I think this two data is enough for you people. Yeah, you can start answering.
Excuse me, sir.
Yeah.
Sir, in last problem, sir, for truncated 1
Hmm.
sigma, sir, for minimum clearance, I got minus 0.014, sir.
How it is possible? Yeah.
XA bar is 0.12, no, sir.
Sorry.
XA bar.
I think what happened is my XA bar. Just a minute, something. Let's hang with the data.
You don't drive, man.
Sorry, I created a assignment as a tolerance analysis, numericals on tolerance analysis. I think you can just post your answers over there. Okay. DFMA numericals on tolerance analysis. So that is the assignment title. So you can post all your sheets over there. Okay.
Yes. So fundamental deviation of the shaft.
I given no 0.065 millimeter. Is there?
Yes, sir. Thanks.
It is there.